fair while, guys, so please stick with me. Imagine this will take close to nearly the whole period to go through these examples, but we'll see how we go. We've got 2 examples I would like to get through. We'll build up from there. So we're looking at, let's go down to the feasible region question, this one here. So an objective function, what is an objective function? So you'll hear this word saying objective function. You'll see it come up a lot of the time in your exams and things like that in SACs. It's used to describe a quantity that you're trying to make as large or small as possible. So it basically has a line. The objective function can also make it as a line, and you're either trying to find something like that gives you maximum or minimum as possible. So you're going to only look at one of those two. And I'll work through a couple of examples so you hopefully understand that. We have a thing called corner point principle. In linear programming problems, the maximum and minimum values of a linear objective function will occur at one of the corner points of the feasible region. So in a feasible region, you might have a feasible region, say your feasible region is in here. Okay, this is just say, this is your feasible region in this area. And we have these things called corner points. Okay, so you've got the corner points here, 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 and here. Okay, so you might have all those ones, the corner points. You can test each of these to see which one gives you the maximum or minimum out point, depending on what you're getting for. Sometimes these will be nice whole numbers, it might be like 13 and 12, and that's good, so you can substitute those values in. But sometimes it might be like, 13.3 and 12.2. Sometimes it's okay to substitute in decimal places, but in terms of the context of the question, you may not be able to. So the last subchapter that we'll be doing is we'll be looking at, well, if I can't do decimal places, then you've got to look for the nearest integer, the whole number. So then you've got to start like looking in there. So it might be, if that's 13.3, then it might be 13, and it might be 13. You might have to actually move like back in a bit and up a bit to see what your maximum output is. So that's kind of where we're going. For the moment, we're just going to look at corner points and sliding line methods. So they will be the answer. Other times you can't actually use the corner points because they're decimals, and we need to look at like the whole numbers in there, and that's what we're going to do in next lesson. So that's kind of where we're going today with this. So let's get into it. Let's look at an example and try and see. So a lot of this will be what we need to do until we get down to this question here, and then hopefully here we'll be able to figure out, that's why it works how it is. I like red wine, so I thought this would be a good example. A wine company has 2 top-selling wines, Barbecue Red and Red Velvet. So they're really, both wines are a blend of wines made from Cabernet, and Shiraz grapes. So sometimes you can get like Cab Sav or Cab Shiraz, but they blend these together. Okay, so basically they produce 2 different types of grapes. One's a Cabernet, one's a Shiraz, and they like ferment those and make those into wines. But then you've got like 2 different wine barrels, one's made like you got the Cabernet wine barrel here, then you've got your Shiraz that's made from the grapes, this is your Cab, this is your Shiraz. And then they actually take different proportions of those to make what we call a blended bottle of wine, which is basically all the different types of wines that you can get. The proportion of Cabernet and Shiraz grapes in Barbecue Red and Red Velvet are shown in the table below. So to get a Barbecue Red, so to get the Barbecue Red, okay, that uses 0.2 of the Cabernet to 0.8 of the Shiraz. So, you put in, if this is like a litre bottle, you put in 200 ml of that and you put in a litre of this. Now, obviously, we're talking about a big quantity because it's a manufacturing place. Red Velvet, though, uses more Cabernet. So if you've got Red Velvet, the bottle of that, it has a different blend. So it's got a different ratio, basically. So it will have, so this one will have Cabernet 0.2. This one will have Shiraz 0.8. Where Red Velvet will have Cabernet will be 0.7. and Shiraz would be 0.3. Okay, so that's basically what the scenario is here and what we're doing. So we have these 2 wines, Barbecue Red Red Velvet, and it comes from making those of mixing the Cabernet and the Shiraz wine together to do that. So I'm trying to give you some context of this to actually show you why it's applicable and how we do it so you can follow through with this. So obviously the company, they don't just make one wine, they have allocated 14,000 litres. So sometimes when you actually do like a harvest, you know, they make, it's a small winery, this one, that's not a lot of litres. The company has allocated 14,000 of Cabernet. So they have 14,000 litres of the Cabernet that they've made, because remember they'll be like in big vats, these things, you know, and they've got like a huge stainless steel vat and they've like obviously fermented it. And they've got 14,000 litres of that in there of Cabernet. And then they've got 24,000 litres of Shiraz. Okay, so they've got massive ones, and from there they do that. They've got 24,000 of Shiraz and of Cabernet there. We're going to let X be the number of litres of barbecue red that the company manufactures, okay? And Y be the number of litres that Red Velvet, the company, manufactures. So this would be Y, okay? So we've got, this is X and this is Y. So that's the number of litres. In terms of X and Y, one constraint on the company's ability to produce as much blended wine as they like is 0.2x plus 0.7y equals has to be equal to or less than 14,000. I'd like you guys just to spend 2 or 3 minutes from this information, write other 3 constraints that apply. 3 others for me that apply. Have a go at that one. Give you 2 minutes, see if you can come up with that one. So grab out a pen, paper. You also want to get out your CAS as well, and have a go at that one. Give you guys about another minute, and then I'm going to pick on, or Alina, I might ask you, what do you think one of the constraints would be? And if not sure, I will help you get through it. There's a lot of people struggle on this normally. How are you doing, Alina? And please use your microphone for me. I'm not sure. Okay. All right. Alina, work with this one. We've got this constraint one. What constraint do you reckon this is showing? How do you reckon we got this constraint? Please use your microphone. It'll be a lot easier.
I honestly have no clue.
Okay. So where do you see these numbers? Where have these numbers came from? Where do you see this, this, and this? Where do you see point? Sorry?
In the table in the question.
Right, so what do you see? 0.2x plus 0.7y has to be less than, or can be no more than, or equal, can be no more than 14,000. let's think about that. So this table is showing what? It's showing Cabernet, right? So X is the number of litres of barbecue red that the company manufactures. So if it produces 1 litre, it's going to use 0.2 litres of Cabernet and 0.7 litres of red velvet. And the total of this needs to be less than 14,000. Why does it need to be less than 14,000?
Because that's how much the company has allocated for it.
Right, that's how much they've allocated for the Cabernet. It says they've allocated 14,000 for Cabernet. So that means, well, for every litre of red barbecue velvet you use, you're going to use 200 mils. And for every litre of red velvet that we're going to use, we're going to use 700 mils. So that's why we've constructed this constraint. So there's another constraint here with Shiraz. Can you have a go at what that one may look like?
Do you want me to put it in the chat?
No, just tell me what you think it is.
So would it be 0.80x plus 0.30y has to be less or equal to 24,000?
Spot on. Spot on. So what you can do, guys, is sometimes you can look at what the other equations are, or inequalities I should call them, and then you can go, hang on, if that's like that, that's like this one. So you can kind of make your way through if you do get stuck like that. But that's spot on. And let's think about this, right? Just think about it in practical terms. We've allocated 24,000 litres of Shiraz. So really, I can't go use any more than 24,000 litres of Shiraz. So that means I can only produce, if I used everything for Shiraz, but we know that if I use a bottle of red barbecue red uses 0.8 litres of Shiraz, where Velvet will use 0.3 litres. So if you actually tried to solve this on your calculator, you divided it across, you can say that if I go, go away. So if I go 24,000 divided by 0.8, if I just only made red barbecue red, the amount of the bottles I could only get would be 30,000 bottles, because if 30,000 bottles would use 30,000 bottles, if you times that by 0.8, that's how many. That's how many liters is in each one. 800 mils. That gives you 24,000 liters. So that's why your constraint is like that. But you've also got the red velvet, which uses 300 mils. So we know that the total amount, because we've got this restriction on Shiraz, the total amount of liters of the Shiraz is restricted from how much I use per liter of barbecue red and how many I use per litre of red velvet. Does that help a bit, Alina? Does that kind of make sense or not? Because I'd love to explain another way if not.
Yeah, that makes sense. Thank you.
Yeah, okay. Work with me on the next one. The next two are always hidden, and they're actually really the easiest one. And you're always pretty much going to have these. 99% of the chance you're going to have that. And it comes down to just the constraint of X. What values can X be? More importantly, what can't X be? And think of, let X be the number of litres of barbecue red. I could produce infinite amount of litres of it, right? Obviously, you're restricted with these two, but in theory, could I make as many? Would you agree? Alina?
Yeah.
Yeah, okay. What can't I produce on the number line? So I can go infinitely positive. Can I produce -1 litres or -2 litres?
No.
No. So that's a constraint. So X needs to be greater than what?
0.
0. Yep. So X needs to be greater than 0. So all you got to do there is you can either do it this way. It can equal 0. Can I produce none of them?
Oh, no. So 0.
But I can produce nothing if I wanted to, couldn't I?
Yeah. Okay.
Yeah, so I can. Yeah, because I can do none. So like before, I said, let's just produce only barbecue red. That would leave you with none of the red velvet, right? So you can do that. So you can write it as that. You can write it either way. You don't write both, or you can write it that way. And it's perfectly fine either way to write it, okay? It doesn't matter. And that means also then we're also going to have another constraint with Y. Y can't be negative liters. Like you can't produce negative liters of something, like you either produce it or you don't. So that's why the constraint is there. Does that help, Lena?
Yeah, it does.
Awesome. Whoops, and I didn't do this right. Sorry. Like that. X needs to be greater than 0, or I can do. Awesome. Thanks for your help. I'll keep on moving on. So now we want to plot these constraints on a set of axes and clearly indicate the feasible region for this solution. Label the coordinates and the key vertices defined for the feasible region. So grab out your CAS, guys. We're not going to plot this. We're just going to do it on a CAS because I'm just going to show you how you can transfer things from your CAS onto this. And then I'm going to take a screenshot of it and we'll use that. Again, let's just do, at school I'd normally do this on Desmos, but because I'm not there, it's going to be way too hard for me to do it. So we're going to clear all in here. So the first constraint. Now notice this constraint, we can only write in terms of Y or in terms of X constraints. So what we need to do is go into our main. And what I'd suggest you guys do, especially with these inequalities, unless you're good at dividing and multiplying and things like that, it's pretty easy just to type in your equation here. 0.2x plus 0.7y. Bring up your keyboard and you'll find these figures in, where are they, Maths 3. Make sure you get your inequality right. Make sure you get your symbols right, 14,000. And then we can solve it for either X or Y. I would personally probably rearrange it just for Y because you can. So change this to Y, hit execute, and we've rewritten our inequality in terms of Y. If you get this number, like I have, I've clearly stored a number in for X. So you just go edit, clear all variables, hit OK, and just hit execute again. Notice it's came up in decimals. You want to make that either standard, so I can execute, and then it comes up as a nice little inequality, which isn't really good, but let's just whack it in. As long as I type these in correctly, it's fine. So the one thing you want to do then is highlight that, hit edit and copy. But you really want to take note of the way the inequality is. Sometimes I actually copy the whole thing because I forget which way it is. And then I'm going to go back into graphs and tables, paste that, and then I can see which way the inequality is. Double tap on the equals, and then I can make sure before I delete that that's the right way. Then I click here on my stylus. I'm happy with my inequality. I just backspace that and then done, hit tick, hit execute, and that is my first one rearranged. So I'm going to just show you how to do that again. So again, I'm just going to type in the next equation, which is 0.8x plus 0.3y, keyboard 3, do the inequality the correct way. Why I say this out loud is because I know I stuffed that up. So I've picked up that's my fault. So I'm sort of speaking out when I say, hey, make sure I put the inequality both ways. That's something I know I always stuff up. Again, I'm double checking my inequality because I've made that mistake so many times doing these questions. So when you guys go through and do questions, if you do that simple mistake or any mistake, put in some measures to help you from making those ones. Interactivity, advanced, solve, and I'm going to rearrange it for terms of Y. Again, I'm just going to copy the whole thing because I know I just transform my inequalities around the wrong way. So I just like to do that just as a double reassurance for me. And why I'll take my time on this is because these questions are normally like a long question. So I would just check and do it. So I need to double click on that, change my inequality that way. Click on here, backspace, backspace. And that's how I kind of go about doing it. Now, these two equations are different, which is good because I've done two different equalities. The next one is here I could do with Y. Let's just do Y, seeing as we're on Y. I'm going to do that way. It needs to be greater than 0. Execute. Y is greater than 0. And then we know X needs to be greater than 0 as well because we can't produce negative leaders and we've got them all in there. Now, before I graph this, hopefully you guys are sort of caught up with me. I've got to think about it. X and Y represent what? X and Y represent the number of liters of bread barbecue and velvet, right, we can produce. Now, remember before, I know that's about 30,000 here. So I'm going to just make my axes because I could, if I just produced, I think those, it was 30,000. So I'm going to make my axis, I'm going to make my axis about X, maybe minus, let's just make it minus 50. because then we can see a bit better to at least maybe 30,000, just as a ballpark. And we'll do scale of, let's do scales of 1,000, just so it's nice and easy. Y, I'm going to go to -50 as well, and I'm going to go up to, let's go to 35,000, sorry, just to give us a bit of room. And Y max to 35,000 as well. Scale, make that 1,000, your scales, because then it will be a bit easier. And we'll dot 1,000 as well, and then hit OK to that. We'll see what that looks like, because then your scale's there. So let's draw this now. And that is our feasible region, okay, which is pretty good. Which kind of makes sense, because obviously I could produce no liters of anything. So I could definitely have that. So how do I find these points? I'm going to go analyze GSolve. So if I was sketching this, so I want to like actually do a quick sketch. So I'll just quickly do a quick one. Actually, I'm just going to take a screenshot of this. So usually you don't actually need to graph this whole, a lot of the time you don't actually need to graph the whole inequality. You just need to put one line on a graph, like one inequality. But it is good to know how it works from start to finish. Okay. Let's make this a bit bigger. So now you might have to label the points on here, or you might have to label a graph. Either way, you just come on and do that. Let's label the points on here. So the first thing I'll do is be the x-intercept. So I'm going to analyze GSolve, and I'm going to do y-intercept. But notice that line comes up first, so because it's already flashing, I just hit execute to that. Otherwise, I can do the y-intercept for that one, but I don't really care. So that is 0 and 20,000. So I'm going to put a dot here, and I'm going to write 0, 20,000. What's really good to do is also to label your lines. You can see that that line there is blue, matches to the blue of that color. Because this is red, that is red. This is green, that is green. This is, I don't know, purple or something that goes there. So I'm just going to write my inequality on here, just so I know which one's which. And this is the blue one, which came from my first equation, if you recall, which was 0.2x plus 0.7y. Needs to be less than or equal to, I think it was 14,000 by memory. Just double check that. Yep. And the other one's going to be 0.8 plus 0.3. I mean, you don't, if it says label the graphs, if it says label the inequalities with their, or label with their inequalities, then that's what you got to do. Was it 26,000? 24,000, 0.8, 0.3. Oops, and that should be y. Okay. Then you've also got, this is y needs to be greater than or equal to 0. And this one needs to be, you've also got x is greater than or equal to 0, which is along there. Okay, let's find the point of intersection. Now the point of intersection will be pretty easy because it's only two graphs really, but that will come up. So GSolve intersection. So we can hit execute. Yes, I want to do that line and I want to do the red line. Hit execute again. And it tells us what it is. It also tells us down here. So I'm just going to do a point there. And that is 25,200. Oops. Right. 25. That looks like a 3 to me. So I'm just going to really make that clearly. 25,200 and 12,800. Okay, this point down here, I want to find the x-intercept for that, which is the root. Now, I don't want to find the root of that line because it's like way over here. So I'm going to just press down and do that one. So it's 30,000 and 0. Now, one thing that a lot of people stuff up on, all the corner points. Now, if it said label all your corner points as axes, have I done all the corner points as axes? Not yet. Literally look at it. Like, sorry, label all my corner points as intercepts. That's a corner point. That's a corner point because it's looking at the corners. This is a corner point. You've also got this one. And a lot of people stuff this one up and just leave it out. So that's 0, 0, which makes sense because you've got the corners. Okay, so that's really where we're trying to go. So hopefully that's nothing too new in terms of labeling those. Maybe creating the equations are and doing that. Label the coordinates of the key vertices defining the feasible region. So I've labeled the coordinates of key vertices, which means the corner points. So I've done those, okay, as coordinates because it says plot these constraints on a set of axes and clearly indicate the feasible region. I haven't done that. I would color that in the same color as that, so that should be blue. All right. Okay. Clearly indicate the feasible region for this situation. 1 point for that. Hit a key and that. Label the coordinates of the key vertices defining the feasible region. I've done all the points of them. 1, 2, 3, and 4. All right, let me just bring up the next question. Okay, the company makes a profit of 80 cents a litre on barbecue red and $1 profit on rubber vert. This is the new stuff. Write an equation for the profit made. P, if this company produces and sells X litres of barbecue red and Y litres of red velvet. This is the objective function. As soon as they start talking about like a profit and you get money and it says write an expression or an equation. So I want to write an expression. I probably should have said write an equation because technically an expression is just 0.8 litres of the barbecue red. Barbecue reds is X plus 1y, and that is in dollars, okay? That's the expression. I'm going to write it as an equation for the profit made, okay? If the company produces and sells X litres of that and Y litres that, so they produce it and they sell it. So that's what we're kind of looking at. So that is my profit, because if I sell, 10 litres of the barbecue red and 5 litres of the velvet, well, I'm going to make 80 cents a litre on that. I've sold 10 litres, so I'll make $8 on that. And I sold 5 litres of velvet, so I'll make 5. So if you put in 10 here, it's going to give you 8, 5 there, it will give you $13 of profit in total. Any questions on this one, how I came up with this profit formula? Don't get confused by break-even points here. Separate break-even points. We do not do break-even points with inequalities. Okay, that's something I really want to point short. If you're working on an inequality question and something like this comes up, this is your objective function and the things we're going to do with it. That's the only thing you're going to do with that, basically. Any questions? Can you say X plus Y is less than or equal to 38,000? Yes, you can. No, because you can't. Because X is the number of litres of red that the company manufactures. That cannot be less than 38,000 because red consists of 0.8 of Shiraz, and you've actually only got 30,000 litres of that. So you cannot do X plus Y is less than 38,000 because X represents the number of these that you make, and that is dependent upon what ratios you have. So you're limited to that. So if you look at, let's just have a look at this. Let's go back to our graph. So how do these inequalities work? Well, if you think about this one, let's look at the Cabernet. Let's look at the Shiraz. If you look at Shiraz, barbecue red takes 0.8 of Shiraz and red velvet takes 0.3. So if we look at that one here, that is this equation here, right? This point means that you can produce 25,200 litres of X, which is our barbecue red, right? Because this is our barbecue red axis. And this is my velvet, right? That's my red velvet axis on this one. That's how many you can produce. So how does this work? This corner point just says, hey, I make no barbecue red, but I make 20,000 red velvet. All right, how does that work? Can that work? Well, if you just make no barbecue red, but you make 20,000 red, what is going to be your first limit? Well, let's get on a calculator and have a look at that. If you've got 14,000 liters of Cabernet and so all you're doing is making red velvet. So how many bottles can you make of just using the red velvet? Well, you've got 14,000 of Cabernet. So if I go 14,000 divided by 0.7, because it's 700 ml a bottle, 700 mils in a liter, I can make 20,000 bottles. And if we just look at the Shiraz, well, the Shiraz, you've got 24,000 liters. And you divide that by 0.3, well, you could make 80,000 liters, but you're limited by your Shiraz, by your Cabernet. Your Cabernet lets you only use 20,000. So the amount of where are we? The amount of Shiraz that you would actually use would be, we use 20,000 bottles times by 0.3, because you'd make that many. So you'd use 6,000 liters of your Shiraz. And if you have 20,000 liters, and you would make times 0.7, and you use all of the Cabernet. So you're throwing out a lot of your, what do we use? We use 6,000 liters. Yeah. So you're throwing out basically a lot of your Shiraz. So you've got 6, 12, 18, 24. So you're throwing out 18,000 liters of your Shiraz unused. So that probably wouldn't be too wise, okay? Whereas down here, you're producing 30,000 liters of your red barbecue and no red velvet. So if you look at that, 30,000 of your barbecue red. So your Shiraz is the predominant one in there. So you'd find that would actually, if you go 24,000 divided by 0.8, that's going to be 30,000. So you produce 30,000 liters. But your Cabernet, if you produce 30,000 liters of it by 0.2 in each of them, you're only going to use 6,000 liters of your Cabernet. So again, you don't have you're throwing out, what's that, about 8,000 liters of Cabernet. So you can probably see that this point is going to be the sweet spot where you find the right ratio of how many you need to use, okay? This will maximize, right? This will maximize using the most amount of those. So if you produce 25,200 of barbecue red and 12,800 of red velvet, that would maximize the amount of stuff that we use. So 25,200 is down. Is okay. So when I go up here and we look at this, so we produced 28,000 of barbecue red. So you'd find that would use, we can actually look at how much you would use on there, and you'd find you'd use all your liters up. So if we did 25,000 of these, 5,200 of the red barbecue. And then if we do 12,800 of that, okay, what would we use? So let's figure that out. So we've got 25,200, and we're going to times that by the amount of Cabernet that we use. So the Cabernet, amount of liters that we used. And then we're going to look at Shiraz. So we've used 5,040 liters. And then we did 12,800 bottles, 800 liters, I should say, of the other one of 0.7. So you've used 8,960. So together, we've used 14,000 liters. And if we look at the Shiraz that we've used, so the Shiraz for the barbecue red is 0.8, so it's 25,200 times by 0.8 is 20,160. And the next one is we look at Velvet Red, which is yellow. So we used 12,800 litres, and that is going to be 0.3. So you use 3,840, which uses a total of 24,000 litres. So that gives us our maximum usage that we can get into there. All right. However, that may not be our maximum profit point, but we're going to look at that. So let's have a look at it. So we know that this gives our maximum profit. This is our objective function. So we're trying to just unpack what's happening here. Determine the amount of each sort of wine that should be sold to maximize the profit. This is where we really want to test our corner points. So we actually can substitute in each of our corner points. Okay, so there's two ways to do this. Test corner points. If two corner points give same value, the whole line segment is the solution. If one corner point if one corner point gives maximum, this is the solution. All right, so let's test in corner points. Well, we have our corner points. We've got 0 and 20,000, so we've got a few options. We have 0 and 20,000. We also have 25,200 and 12,800 that we can produce litres of each of these. Okay, and we also have the other one, which is producing 30,000 of the barbecue and none of the red velvet. So that's none of the barbecue, 20,000 of the velvet, 25,200 of the barbecue, 12,800 of the velvet, 30,000 of the barbecue, and none of that. And then you've also got 0, 0. Let's look at the profit for each of these. So my profit for the first one would equal, I sold none of my barbecue. That'd be 0.8 times none of those, plus I sold 20,000. I can make 20,000 litres and sold of my red velvet. So that's just 20,000 times 1. So my profit for the first one would be $20,000. Okay, so that's for that one. Looking at this coordinate, my next one, okay, my profit for that is going to be, well, I get 80 cents for each litre of these that I sell. And $1 for the other ones. My profit for that is going to be $32,960. Right, and then for my last one, I can do 0.8 times 30,000 plus 1 times 0. That is going to give me $24,000. And my last point is just going to give me 0 because it's going to be 0 times 0. So the maximum one would be to sell this amount, right? Which is pretty obvious. So what is the maximum profit? So the maximum profit I get is 32,960. And it said and then if I went on to say, well, by selling how much, you'd be say by producing 25,200 litres of the barbecue red and 12,800 litres of the velvet. So you can see there how it kind of that works. Okay, you can hopefully see there how that works with that one there. Now, you might be like, well, that was pretty obvious. I could see that that was going to be the point anyway with that. One thing that we can do is you can actually, and I will get back into this next lesson, and I'll show you the sliding line method. But I'm just going to change it up slightly for you guys. I'm just going to change up this, okay? I'm going to change up this question, and I'm just going to say, let's check this out. Let's do another question, just slightly. I'm going to change it to this. Company makes a profit of 80 cents per litre on barbecue red and $3 profit on red velvet. Okay, write an equation to show me this. So it's still 80 cents on that, but we've got $3 on the red velvet. Okay, so you might think, oh yeah, well, it's pretty obvious that was that point there that was there. Okay, well, obviously, because that's where you make the most. But let's look at the profits now. Okay, let's look at the profits now. Well, we know that we have a few corner points. We have, just look at these ones, 0, 20. So 0 and 20,000 would give me my profit equals 0.8 times 0 plus 3 times 20,000. That's going to give me a profit of 60,000. Let's look at the next point. Let's go with 30,000 and 0. Profit equals 0.8 times 30,000 plus 3 times 0. That's going to give me an answer of 24,000. So that's not very good profit. And obviously you're going to go, oh, well, the corner point's going to give us the most, right? We've got 25,200. We don't need to do 0, 0 because we know that's going to be, there's nothing. I think it was 25,200 and 12,800. Let's just put this in. Profit equals 0.8 times 25,200 plus 3 times 12,800. So you make obviously good profit on the other one, right? And this is where your inequalities come into it, because you might be like, oh, let's just make as much wine as we can, you know? 800. Okay, so my profit there is 58,560. I'm better off not even selling and producing any barbecue red and just producing more liters of my red velvet. So really, then what I'd want to do, because I make more profit there. So what I'd really want to do is start thinking about, well, what land I'm using. And if I'm, using my land and I'm not really making as much money from the barbecue red, I would obviously then want to really start producing more or change my setup in my winery to produce more liters of the, if we look at it, where we go back to Y, then you'd be like, well, if I want to produce more of that, I'll probably want to produce more Cabernet and less Shiraz. So I want to get rid of my Shiraz fields and grow some more Cabernet. So don't always think that that point's going to be a maximum. Obviously, in this case, it is. But there's one thing you can do is you can actually plot out the gradient, look at the gradient of the objective function. And if we looked at the gradient of these objective functions, you would find that when we slide it, that would get to your maximum point, where the other one, that would be your maximum. And that's what we're going to pick up next lesson. So I'm going to leave it there. Hopefully you get an idea of the objective function as we make an equation, and we can test the corner points of those. And then when we test the corner points, we can then figure out, okay, which one gives us our maximum points there. Really, guys, for your homework, I would suggest catching up to 10L if you want to. One thing I am going to get you guys to do is I will write down just the questions I want you to try from 10M before next lesson. But that is it from me. Sorry I went a while over. I said it will be a while, but we'll pretty much finished off next lesson as well. This will cover pretty much the main concepts. This is a difficult one. Cheerio. I'll leave it there and we'll pick up next time. Bye now.